Let's get specific. Let's talk about the RF module. This is the heart of the entire transmitter, and it's the same module, whether it's the 3.5 or the 44 kilowatts.
That's right. We've built in redundancy with 6 fans at the bottom for adequate cooling. The PA or power amplifier, there's 8 of them for a total output power capability of 3,000 watts. There's an intermediate power amplifier that's been designed into this, which eliminates the external switching and single point failures that some of our other conventional systems may have had. The system is completely hybrid split and combined, and it's a very compact module.
We'll see the block diagram of it in a second, but I think the key thing to understand is that that IPA module that is in there is one for each individual module. So, you know, an IPA is typically a single point failure in an FM transmitter, and it's not in the NV series.
That's right.
That's wonderful. All right, so let's take a look at the block diagram of the entire transmitter. Tell us what we're looking at here up in the upper left-hand corner, Scott.
Well, in the upper left-hand corner, it highlights the level of redundancy that we've designed into this transmitter as a standard feature. We have the IPA supplies that come redundant. You can see in an NV40 system there are 3 with a third as a redundant system. The low-voltage power supplies, AUI and single-board computer supplies, and the fan supplies all come as standard redundant units.
So in a lot of people's transmitters, even our own in the past, you could have redundant supplies, but you paid for them, and it was quite expensive.
That's right.
In this NV series, all the way down to the 3.5, it's standard.
Again, keep the customer on air.
That's right. Okay, so we have the opportunity for 2 exciters here. One is standard.
Yes, and one is optional. The switching system and circuitry and control are all standard, so upgrading to a dual exciter is definitely an option for all users.
So then here is our 8 modules in total, and I noticed here that the whole thing is combined with 3 dB hybrids, and that has a huge advantage of turnaround loss.
Turnaround loss is a big concern for customers, and this system has better than 20 dB turnaround loss, and I don't think you'll have any issues with interfering with adjacent channels.
So if you're sharing the tower with another FM station, or you're using a separate antenna method for HD combining, you've got better opportunity to minimize RF-IMD because of this turnaround loss.
Be a good neighbor.
That's right. Okay, so let's walk through this from an RF standpoint just for a second. How much power does one of these exciters put out?
The exciter is capable of a very conservatively rated 200 watts. Obviously, it's transmitter dependent, but for an NV40, for example, you're looking at nominally 150 watts.
And so if you've got a 16-way splitter here, you're looking at almost 10 watts per module.
That's right.
And then the IPA takes it from 10 watts to what?
The IPA provides 100 to 120 watts, depending on frequency, for the 8 power amplifiers.
Now that IPA is rated for what, 375?
375, again, very conservatively
Lots
rated.
of headroom. Then you've got the 8 modules that takes it up to 2.5 kilowatts, but really the module is capable of
3 kilowatts.
3 kilowatts. Okay. Let's go down here and zoom in on the RF module itself. So this is what we were just talking about. You can see there's a lot of reflectometers built in here where we can actually see the power going through here. And I understand there's something about the quality of the directional couplers. Is that right?
Yes, actually, we have directional couplers in the module. We monitor the various stages. They give a decent level of directivity to provide adequate accuracy in the module. Our transmitter forward power probe actually uses true RMS detectors to give you the best accuracy in IBOC modes.
Sure. Okay. And I see that we're even monitoring the power that's going to the reject load that's built into the module itself.
That's right.
People haven't had that kind of granularity in their visibility before, I don't think.
Right.
Okay, let's talk about the redundancy build. We talked about it, but let's see where it is.
Okay, so physically, if you look at the transmitter, we've got 8 modules. Again, a lot of redundancy just in the RF section. If you look down at the power supply section, you'll see physically the IPA supplies are located in the bottom left-hand corner.
Okay.
The right hand is the fan supplies. The exciters are to the right. Again, this depiction shows the optional exciter installed. And yes, so there's a high level of redundancy.
For a second, Scott, tell me what happens if one of these modules in a 40 kilowatt goes out.
Well, of course, there would be a power reduction unless your assigned power level were below limits that have been predefined, where the transmitter will allow the modules to turn up to overcome those certain soft failures.
Rough numbers, what are we talking about in a 40 kilowatt?
Well, for one module, you're looking at about 90%. If you look at statistically failures that occur, you're looking at 1 or 2 PAs perhaps, and it's almost negligible, Chuck.
Okay, so you really wouldn't be able to tell that you've lost a PA transistor or something like that.
That's right.
All right, so we have hot pluggable power supplies here as well.
Yes.
And you mentioned that the power supplies are actually the same power supplies that are used for some of the other supplies, the IPA and the fan.
That's right. So if by some chance your redundant supply, that again is standard, were to fail, if you felt you wanted to keep that same level of redundancy, you could always take one of those power supplies, pull it out without switching anything off, and plug it into that spot.
Let's talk about redundancy in some of the other things, like the cooling fans. And there's a lot of cooling fans in here. Why did you put so many cooling fans in?
Well, again, soft failure. We know that things have a life expectancy. Fans are one of them, and I'm sure most customers are concerned about fans. We provide enough fans to provide adequate cooling with the knowledge that one fan may fail. And again, fan removal and replacement is quite easy with these blind mate modules.
And we've provided the cooling so that the transmitter will operate into an ambient temperature of 50 degrees C. And we actually test that here, don't we?
We do, yeah. We actually build a tent around the system and do significant verification validation testing to ensure each system is adequately rated.
Now, we have parallel RF combiners and filters. On a typical FM transmitter, you've got one harmonic filter at the output of the transmitter, but you don't have that here, do you?
No, actually, we break this transmitter down into 10 kilowatt blocks, basically, and that allowed us to scale the system all the way from the 3.5 kilowatt mark to the 44 kilowatt mark. So each 10 kilowatt block has their own low-pass filter.
Okay. That's one thing that some people ask me when we go to a trade show with the NB40 is they say, is that all there is? Where's the power supply cabinet? How big is the low-pass filter? And they are a little bit incredulous when we tell them that's all there is. That's all there.
Size can be shocking. Yes.
Yeah. Okay, let's talk about the power controller here. This is the main controller in the transmitter.
It is. It's in a sense a single board controller that takes in all the telemetry, meters, and distributes the streaming data to the AUI for metering. It also takes the controls from the AUI for the control functions. The nice thing about this board is the backup controls that we've designed into it. You know, we understand that the AUI is another point that could at some point become non-functioning, and we've built in the redundancy that the transmitter will keep operating, and the user has a full set of controls, and he can increase, decrease power, turn on, off. He can do all of the things that he can do on the AUI.
So you've got some PC buttons right here, right on top of the PC card. They're labeled and the typical functions. And then down here, I believe there's some indications of monitors.
There are. We have the rudimentary alarm and status.
Okay.
We have a power meter that indicates in 10% increments where you are with respect to maximum power.
So that's one level of redundancy, and then you've got another level of redundancy over here, don't you?
Yeah, this is the remote board. This allows customers to connect parallel connections and monitor and control the system. We've got LEDs and push buttons that simulate remote controls. That way, when the user is in a local position, he can test his remote functions and get feedback via the LEDs.
Okay, so to summarize what's going on this card on the right-hand side is these are the places where you'd connect up your Burke or your sign systems or what have you.
That's right.
And then in parallel with that, you've got buttons and lamps that you can program by the AUI to have any functionality.
Right, to give the user a kind of a local impression of what is happening remotely.
Now,